So let's just do a quick chat here. So I'm from a company called Canadian Association of Chemical Distributors, and we're responsible, our members are the guys that are shipping the chemicals across the country. What I get to bring to you today and encourage other schools to use is You Be the Chemist. So these guys here, this is Troy, this is Maya, and this is Claire, and they're kind of our poster kids for science. And they're different ages because our program is for kindergarten up to grade 8. And we've got lots of fun, exciting experiments for you and for your teachers. So the first thing we need to talk about is safety. So today we're not going to be using any chemicals that are hazardous, which means we don't have to wear a hazmat outfit, we don't have to wear secluded lab gear and all of those kinds of things. But we still need to be safe. So what's something that you think we should always protect? Cat. Our eyes, excellent. So not by coincidence, you have safety goggles in front of you. Let's put those on. If you have glasses, we've got safety goggles for glasses. So I'll put those over here. The other thing you should do is protect your sleeves today. So let's roll our sleeves up. We're not using anything hazardous, so our arms are not a concern. But for now, let's just make sure our hair is behind our ears for anyone who has long hair. Okay? So just before we get to our goofy putty, I have a question. Does anybody know what a polymer is? Let's go, Kat.
It's some sort of organism?
Very good. These are very good answers. But today I think what I'm going to do is going to give you an example of how a polymer is created. Okay, so I need 4 ladies and 4 gentlemen. So before we get to a polymer, we have molecules. And before a molecule, we have what's called monomers. So monomers are teeny tiny particles. So right now, individually, they are what's known as monomers. So teeny tiny molecules, okay? But to become a molecule, they need to get larger. So we are going to add Aiden to Mitchell, and they are now individually a molecule. Does that make sense? So the other way we can think about it is, if we were going to make a cake, the girls would be the flour, and the boys would be the sugar. So individually, they are molecules. But to create a polymer, to create our cake, our final product, we have to put them in a pattern, larger state. And typically, they are known as pattern large groups in long chains. So now we have these other molecules that are floating around us. We have to add them in. So what are we going to do? We're going to make them a pattern. So now, because they are in a pattern, we've got female, male, female, male, female, male. They are now a polymer. They're a large group in a pattern state. Now they reflect our cake, because now we've got our sugar, our flour, our water, our milk, our eggs, all of that in one component. The other thing we're going to talk about today is measurements and mixtures. So the other way to think about them is right now they're creating a solution. The solution is made up of all the different particles. Lesson number 1 from You Be the Chemist, called Goofy Putty. In front of you, and Mrs. O'Hare, this is great because all of these supplies are stuff that you can buy in a grocery store or in a dollar store, and nothing is hazardous to the skin. But we still always want to protect our eyes, just because sometimes even if like a dust will bother our eyes, right? So in front of you, you have regular white school glue. You have borax in your containers. You have your spoons. Inside of your cup with a teaspoon of water, so you only need 1 cup right now, you're going to add 1 teaspoon of white school glue into that cup, and you're going to mix it really good. So person A, take a spoon, fill the spoon with white school glue, and put it inside of your cup and start mixing. Person A is creating a mixture. Okay? No, I'm not. Yep, that's good. Now just keep mixing it. So pick up your cup and keep mixing. Okay, so while person A is mixing their mixture, I need person B. Where's my B's? Put your hand up. Okay, I need you to come and pick a cup that has 4 teaspoons of water in it, okay? I need you to be careful on this step. We're going to create our borax solution. So again, I'm going to stress, the water and glue is a mixture, borax and water is a solution, okay? So take 1 teaspoon of borax into your cup and mix it well. Make sure it's 1 teaspoon. Any more or any less is going to change the reaction, and we don't want that to happen. So that's another part of science safety, is when we're finished with the substance, we need to close it. We don't want the odors or a spill in the room, okay? Take 1 teaspoon of your borax solution and put it into team member A's loose mixture. We've got, no, that'd be 1 full teaspoon.
It's never done.
Okay? How is it coming?
It's wonderful.
It's wonderful. The student who has the actual Goofy Putty in their hands, if you could come up to the front of the room and let's compare everyone's Goofy Putty. One of the very scientific ways to test this, and I'm making a joke right now because it's not scientific, it's more fun, is we're going to have you come here and we're going to bounce it on the table. Let's do it again. Okay, he's got about 3 inches. Next person. So it looked like maybe 6 inches up, off. Your turn, Beth. Wow, that one's very bouncy. So why do we think that everyone's Goofy Putty feels a little bit different, looks a little bit different, and bounces differently? All right, let's go Catherine over here. That's right. So people put in more or less borax solution. Definitely. Kat?
They might have taken it out earlier.
They may have taken it out before the 60-second mark. That's right. Those are great answers, ladies. And that's true. So what we need to remember from chemistry is sometimes things will not always turn out what we plan for or for what our hypothesis is. Fatima and I just last couple weeks ago tried to do an experiment that, which one was it? The exploding bags, which we've both done individually fantastically. And unfortunately, when we did it together, there was something in the room, something that was changing the chemistry that wouldn't allow us to pop the bag. So that's something we always need to remember, is that the outcomes might always be different, and that's because of the different components that you're working in or working with. Okay? What do you guys have any questions? Any thoughts? You're just all chemists now. Okay, great. Well, thanks for your involvement. If you have any other questions, let us know. We do have some goodies for you. Okay, so what I do need you to do, though, again, as part of science, is part of the cleanup. So if you could just put your cups that have been used and your spoons that have been used into a pile.